Hello everyone, I'm Sungkeun Kim, a PhD student of Texas A&M University. In this video, I'm going to talk about fetch stage of y86 64 sequential processor implementation. Let's get started. Okay, in the fetch unit or in the fetch stage, we are going to fetch one instruction from memory using PC register. But we will read 10 byte no matter what the current instruction size, because it will be very simple to implement and it is very difficult to implement or to read the variable size for different instruction. And then it produces meaningful data or control signal from the instruction for the later stages. So output of this fetch unit would be I code, iFun, RA, RB, RC from the instruction. And then we also calculate the candidate of the next PC value in using val p. And then PC value will be decided in the PC update stage. Okay, let's take a look at the details of fetch unit or fetch instruction. Here you can see blue boxes, instruction memory, split, align, and PC increment. And these blue boxes are hardware module with register and it is synchronized with the clock cycles. Okay, and there are another boxes, gray boxes, instruction valid, I code, iFun, need valc, read, need reg IDs. So they are hardware modules without register and it's not synchronized with clock signal. So you can consider those gray boxes as a control logic that produce some control signal to hardware module with blue boxes. And also in the instruction memory, it will include one register that stores instruction we just fetched and then executed in this stage. And then let's ignore the split and align, because we can directly split this the 10 bytes instructions into I code, iFun, RA, RB, and VLC. Okay. And also let's ignore instruction valid, which is one flag or one bit that indicates whether current instruction is valid instruction or not by looking at instruction code. And also let's ignore instruction memory error because it's not very useful for our project. Okay. And then the remaining is PC increments that updates the PC value for the next fetch. And then to update those instructions, to update PC value, we need to know exact size of current instruction. So how do we know that? We can know that by reading the I code, and then we can see whether this instruction includes register IDs or whether it includes VLC in its instruction. Okay, so these two modules, need VLC and need reg IDs, actually take I code and then generate one bit flag that indicates whether this instruction includes register values or VLC. So here again Read VLC is one bit, generate one bit flag to indicate current instruction includes VLC. And the next module, need reg IDs, is one bit flag to indicate the current instruction includes register IDs. Okay, with these two information, finally we can generate one possible next PC value, which is VelP, with this equation. So PC plus 1, because every instruction has at least 1 byte. And then next is R, which is need reg IDs. And then if it is it is set, then we add one byte here, because the register IDs takes 1 byte. And then if I is set, which is need VelC, then which means this instruction includes VelC, which size is 8 bytes. So that's why we take 8 times I. So then, depending on the signals of I and R, so we can update next PC value. So I mentioned that we can just ignore a line, but actually we can't, because we should align some instruction reading from the memory for these 3 instruction, IR, RM, MR instruction, and jump instruction and call instruction differently. Okay, what I'm saying is basically we want to put register ID to RA and RB, and we want to put immediate values such as V, D, D, and dest into VelC. Okay, but for RI, RM, MR instruction, they have a register field in the second byte, like byte 1. It is natural to read second byte and then put them in the RA. And then when we read later 8 bytes from byte 2 to 9, then they will be naturally stored in VelC. But however, when we fetch, jump, or call instruction, they don't have a field for register ID. So when we fetch second byte of this instruction, they will be stored in RA and RB if we don't have this align module, right? So this align module to output F and F for RA, RB when we fetch, jump, and call instruction, and then output byte 1 to byte 8, which is start byte of dest and end last byte of this dest to the VelC, right? Okay, in summary, so align module takes bytes of instruction from 1 to 9, right? And then it outputs RA, RB, and VelC, okay? But in case of move instruction, like IR, RM, MR, so it will be actually we will put first byte to RA and RB, and then we put byte 2 to 9 to the VLC. So let's say 1 over here. Then let me erase some unnecessary part. Okay, here. Okay, so like move instruction, we put the byte 1 of instruction to RA and RB, and then we put bytes from 2 to 9 to the VLC. But for jump instruction and call instruction, we put just constant value f and f to the RA and RB, and then we put the byte from 1 to 8 out of instruction to the VLC. Okay, so this is the purpose of having a line module. Okay, so this should be taken care by this align module. Okay, inside the instruction memory, we have actual Logisim memory module, and then since the textbook does not specify exact memory information, such as what address bit width is, or what is the data bit width, and also the total size and so forth. So we can define, or we can specify those information when you create a memory module yourself. So this is my configuration or specification. So this instruction memory has 12 bits for memory address, and it has 8 bits for data bits. So output will have only 8 bits, and it is byte addressing. So in total, this instruction memory has 4K byte size, and since it has 8 bit as a data bit width, we can get 1 byte per instruction, per cycle. So for one instruction, we need 10 cycles to fetch entire instruction. Okay, this is it for fetch stage, and in the next video I'm going to demonstrate my implementation with the test program. Then you can see how I test the processor partially implemented in the Logisim. And then in the next, after demonstrate, we'll talk about decode and write back stage. Thank you.